Hello everyone. In this video, we are going to see what is queue, what are the queue operations and applications of the queue. A queue is a ordered collection of elements where insertions and deletions are performed from two different ends. Insertions will be performed from rear end and deletions will be performed from front end. Let me take one example. Assume that this is a queue whose size is 3. Size is 3. Let me write the indexes. So first index is 0, next one is 1, next one is 1, the next one is 2. So insertions are performed from the rear end. From the back side, the insertions will be performed and deletions will be performed from the front end. From the front end. This is the rear position. Insertions are performing from the rear end and deletions we are performing from the front end. Deletions we are performing from the front end. Okay, let me insert few values into the queue. Okay, assume that initially I inserted 10. Next, I inserted 20. The first inserted element is 10. The second inserted element is 20. And the last inserted element is 30. Okay, here the size is 3. How many elements we can insert? Maximum we can insert 3 elements. So when we are removing the first inserted element, what is the first inserted element? 10. So 10 will be removed here. 10 will be removed. The second inserted element 20 will be removed here. The last inserted element 30 will be removed here. So here I want to tell you that the queue follows FIFO, that is first in, first out. First in, first out. That means first inserted element will be removed first, are also called as last in, first out. Last in, first out. That means the last last in, last out. Last in, last out. The last inserted element will be removed last. Here, one of a technical question is, what is the difference between stack and queue? Okay, so if you observe, let me recall this stack once quickly. So this is a stack. This is a stack, and this is the top end. This is the top end. Let me try to insert 3 elements. Here also this assume that the size of the stack is 3. Maximum it can insert 3 elements. Okay. Assume that here I inserted 5. Here I inserted 7. At the top I inserted 6. Okay, first inserted element is 5, next one is 7, the next one is 6. So if I want to remove it, which element we are removing? The topmost element, that means the element which was inserted at the last will be removed. But whereas in the cube, what we are doing, the first inserted element we are removing first. Okay, the difference between the stack and top is that in the stack the last inserted element will be removed first, but whereas in a queue the first inserted element will be removed first. Another difference, in the stack insertions and deletions are performed from the same end, which is called as top end. But whereas in queue, insertions will be performed from the rear end, that is from the back side, and deletions will be performed from the front end. Front end. Now let's see the operations of the queue. First one is full function, is empty, enq, dq, front, and rear. Front and rear. Okay. Now let's come to the is full function. Is full. When the queue will be full. When the queue will be full. Okay. Let me write the front value. Initially, the value of a front is, let's assume front value equal to 0 and rear value equals to -1. Rear equals to -1. As I said, insertions will be performed from the rear end. Insertions will be performed from the rear end. I want to insert one element, 7 I want to insert. What I want to do, first I want to increment the rear value by 1, -1 plus 1. That is 0. -1 plus 1, 0. Okay, the element should be inserted at the 0th index. Let me insert 7. I want to insert one more element. What we have to do before inserting, we have to increment the rear value by 1. 0 plus 1. 0 plus 1. How much? That is 1. At the first index, I want to insert. Let me insert a value 9. Let me insert a value 9. I want to insert one more value. The same procedure. Increment the rear value by 1. 1 plus 1. That is 2. At the second index, element to be inserted. Let me insert 3. Now I want to insert one more element. Okay, if we increment the rear value will be at 3. Do we have third index at the Q? No, we don't have third index at the Q. This is Q. We don't have the third index. That means here the size of the Q. How much is the size of the Q? The size of the Q is 3. That means maximum how many elements we can insert? Only 3 elements. Now the queue is full. Now the queue is full. When the queue is full, when if reaches to, if rear value reaches to rear equal to, okay, rear equal to 2. That is size -1 we can say. Size -1. If rear equal to size -1, the stack is full. Okay, let me write the same thing here. If rear equals to size -1, okay, if rear equal to size -1, return true, otherwise return false. Next function, what is the next function? Is empty. When it is empty, is empty function. So initially what we can say, initially what is the value of rear? If rear equal to -1, then we can say that it is a free. Okay, and let me tell you, if initial value of rear equal to, if rear equal to -1, rear equal to -1, or we can check one more condition. Okay, let me explain through the example. Okay, now the queue is full. Now I want to remove the element. From where we want to remove? From front. Front value equal to how much? 0. At the 0th, we have to remove a element which is at the 0th index. That means 7 to be removed. Okay, 7 to be removed. Yes, I removed the 7. Next, after removing the element, what I want to do? I want to increment the front value by 1. 0 plus 1. 0 plus 1. Now the front value is 1. I want to remove one more element. So we have to remove a element which is at the front value. Front equal to how much? 1. First index value to be removed. Yes, it is removed. After removing, we want to increment the front value by 1. 1 plus 1, that is 2. 1 plus 1, that is 2. Okay, I want to remove one more element. Okay, so we want to remove a element at the second index. Why? Because front equal to 2. Let's remove this one also. As I said earlier, what we have to do after removing, we have to increment the value. Now the value of front is 3. Front is 3. Okay, now front is 3. Now is there any elements are there? There are no elements. Now can I insert any more elements? We cannot insert any more elements. Okay, so here also we can say that queue is full. Why? Because we cannot insert any values. Now front value, how much is the front value? See here, let me write the front value. How much is the front value? Front value is 3. If front value is greater than the rear value, okay, rear equal to how much? Rear equal to rear value equal to 2. If front value is greater than rear, then also we cannot insert it. That means at that time we can say that queue is full. Okay, let me write the same thing. That is, what is that? Front value, if front is greater than rear. Okay, if it satisfy any one of these condition, if rear equal to -1, or if front value is greater than rear, return sorry, if it is 1 second. Sorry, I say that if it is full, it is not full. Sorry, by mistake I told. It is empty. Stack is empty. If rent value is greater than the rate, then Q indicates that it is empty. It is empty. That is rare equal to -1. Then we can say that Q is empty, or front value is greater than rare. Then also it is empty. Then return true. Otherwise, return false. Otherwise, return false. Next one. NQ. NQ means adding the elements into the queue is called as NQ. When can't we add the element into the queue? If it is full. Okay, let's call is full. Let call is full. Okay, if it is true, if it is true, NQ. In NQ, we are calling the is full. If it is full, we cannot add it. If it is true, print the message that what we have to print. We have to print that Q is full. Q is full. Q is full. Otherwise, what we have to do? Which value to be incremented? Rare value to be incremented. Increment rare by 1 and add and insert value at Q of rare. So new value to be inserted. Insert the value at Q of rare. Next one, DQ. Removing the element from the queue is called as DQ. So when can't we remove the element from the queue? If it is empty. Okay. Call is empty. Call is empty function. If it is true, print the message that queue is queue is empty. Queue is empty. Otherwise, print queue of friend. Okay. Otherwise, print queue of friend and increment the friend value by 1. Friend value by 1. Friend value by 1. Okay. So here, if you observe here, when we are inserting rare value, we are incrementing. Next, we are inserting the value at Q of rare. But whereas in the DQ, we are printing the value at Q of friend. Next, we are incrementing the friend value by 1. Okay. Remember these points. Next one. What is the next one? Friend. So which will give the friend value? Okay. So when can't we print the friend value? If it is empty. Okay. Call is empty function. If it is true, print the message that Q is empty. Otherwise, print yes. If it is empty, we are calling the is empty function. If it returns true, print the message that Q is empty. Otherwise, print the value which is at Q of friend. Next one is rare. Rare function. So in the same here also same thing. Oh, rare. What is that? Rare. When can't we print the rare value? If it is empty, okay, empty. If it is true, print the message that Q is empty. Otherwise, print the value at Q of rare. Q of rare. Next one. Applications. Applications of a queue. This also one of a interview question. First one is media player. Assume that I selected the 10 songs and I played it. Okay, all those 10 songs will be stored inside a queue and it will be played one after other in the sequence in the sequence how they stored in the queue. Next one, shared resources. Shared resource. Okay, assume that in a lab there are 10 systems are there which are connected to each other, which is called as a network. Each and every system that is participating in a network called as host. Each and every host contains unique ID which is called as host ID or host name. So these 10 systems are connected to each other. Okay, one printer is connected to, assume that it is connected to system number 1. By using the system number 2 at 10 o'clock, morning at 10 o'clock, I gave one printout which will take 10 minutes to complete it. Yet 10-1, another person by using the second system, by using the another system, he gave the printout. So where that actually the printer is busy with the task that is printing the file, which will take 10 minutes. Okay. Now the second person, another person has given the one more printout where it will be stored. It will be stored inside the queue. Okay. So it will print the all the files which are presented in the queue. There also we uses. Next one. A queue can be used to store list of interrupts in operating system which would get processed in the order in which they are generated. Okay, there also we uses. And if we come to the general examples, okay, general examples, okay, general examples of queue. Grocery store. If we go to the grocery store to buy the groceries, we will maintain a queue. In the same order, it will the person will give the groceries to the customers. Okay. Next one is what the next one? Customer support call center. Assume that at a time multiple persons are make a call to the customer call center. At that time they will pick only, they can answer only few of the calls, the remaining calls will be in the queue. Okay, so there also we uses. Next one is ticket booking. So in railway stations we will stand in a queue to take the to buy the tickets. Next, toll booth. Okay, so in a toll gate all the cars will be in the queue to buy the toll ticket. So these are the general examples of queue.